Good afternoon, and thank you for joining us for today's presentation, Boosting Safety and Efficiency in Sensorless Drive Monitoring. My name is David Schucker. I am Marketing Coordinator for Schmersal USA, and I'll be your moderator for today's session. Before we get this presentation in motion, I do have some housekeeping to do. In your GoToWebinar dashboard, you should have a tab that says Handouts. We do have a couple of items in there for you if you want to download those and peruse them during the presentation or for afterwards. There should also be a tab for questions. And if you have questions at any point during the session, please type them into that window. And we do have a section at the end of the presentation to handle any questions. And if we don't have time, we will respond to any questions that we don't get to in the session. This session will be recorded, so it will be made available after. So if you have any technical issues, you can't see or hear any of the presentation, please leave the session and rejoin, or you can wait for the recording. So for today, we're presenting DINA Elektronik safe speed and standstill monitors. And very quickly, we're going to learn a little bit about DINA Elektronik and how their sensorless drive monitoring works. We're going to see some of the benefits of sensorless drive monitoring. We'll go over some key functions of the various monitors that DINA Elektronik offers. We'll have a brief software demo of the Go Beyond software, and then we're going to provide some real-world application examples so that you can see their product in action. And of course, we'll have some time at the end to cover any questions. Today, I am joined by not one, not two, but three guest presenters. First is Steve Lang. Steve has spent over 2 decades in machine safety, with the last 10 years focused on safety integrations as a TUV functional safety engineer. He also teaches risk assessment and general machine guarding to companies via the Technicum Global team, and he's a member of our Schmersal Canada group. Good afternoon, Steve.
Good afternoon, David.
We also have with us Daniel Matz. Daniel is a TUV certified functional safety engineer and an international sales expert at DINA, with more than 8 years of experience in technical sales and customer consulting. He holds a Bachelor of Engineering from Dusseldorf University and a Master's of Science from Friedrich Schiller University, Jena. Welcome, Daniel.
Hi, everyone. Good afternoon, David.
And lastly, we have Samuel Ayashurno. Samuel is a technical advisor and trainer at DINA with more than 12 years of experience in technical engineering and industrial automation. With a strong background in mechatronics and technical training, he has developed customized learning programs to qualify specialists in automation and drive technology. So welcome, Samuel.
Good afternoon.
Okay, so let's get this presentation started. I think we're going to start with Daniel. Why don't you tell us a little bit about DINA Elektronik?
First of all, thank you, David, for this nice introduction, and thank you for having us. And it's really a pleasure to do this webinar with you together. And yeah, DINA, we actually have already a long history. So we were founded in 1987, and on this slide you see our founder, Dira Najib. This is, by the way, also where our name is coming from. And he invented the first speed and standstill monitoring system in the basement of his home, actually. And yeah, our focus is on safe drive monitoring, and since then we have this focus, and we still have this focus today. today we are more than 70 employees, and we have 2 locations. So it's still the original location, can call it original location, Wolfslugen, which is close to Stuttgart. Of course, the facilities have been expanded over time. And besides Wolfslugen, where the main part of our production takes place, so 100% of our production is made in Germany, we have facilities in Berlin. In Berlin, for example, there's our HR team, our marketing team, some part of the R&D. Of course, some part of the other R&D is also in Wolfslugen, and also part of the sales team sits in Wolfslugen. We have our roots in Germany. However, we are an international company. So in the last 2 years, we served more than 88 different countries, and we collaborate with a lot of distributors and partners all over the world. We also have international customers, and especially we have a lot of collaborations within the Schmersal group. So, for example, we collaborate with you in the US and Canada, but also, for example, with Technicum or Schmersal ACE in Brazil, also with Schmersal India, and even in Germany as well with Schmersal. When it comes to our product portfolio, so as I mentioned, the focus is on safe drive monitoring. And here we have, on the one hand, we have our hardware safety controllers, and you can divide them into mainly 2 product segments. We have the SafeLine Vario, which is basically a comprehensive safety solution, and our modular, fully programmable and parameterizable, configurable safety PLC. The Vario basically has a central unit which offers already a lot of different safety functions, but which can also be extended by several functional modules. There are, for example, function modules for drive monitoring, for field bus communication, for networking, or also cascading. The second product segment is SafeOne. SafeOne is our compact module series, and most of the compact modules are sensorless, and this is what today's webinar is about. So we have, in the SafeOne product segment, we have modules for safe speed monitoring, safe standstill monitoring, and safe rotational direction monitoring, besides other applications, for example, phase monitoring. And in this product group, there's also one, let me say, special product, the SafeOne DS, which is not sensorless, but it's a compact safety control that offers a lot of features in a really small device. So it is encoder based. It can read TTL and sine cosine encoders, and offers on top of that 3 additional safety circles. Besides the hardware, we also offer digital services, which basically complement the hardware modules. So it's the software, for example, our Go Beyond Designer, which is being used to create applications and configure the Vario. Also, it can be used for the SafeOne DS or for the parameterization of the sensorless SafeOne modules, especially the DN3PD2, the safe drive or safe speed monitor.
Okay, thank you, Daniel. Now, Daniel kind of introduced the topic at hand. These are sensorless drive monitors. So, Samuel, can you kind of explain how sensorless drive monitoring works?
Yes, the DINA SafeOne sensorless modules are designed for easy installation and connection. The primary difference between sensor-based systems and sensorless modules is the installation method and complexity. Traditional sensor-based systems require mounting, wiring, and commissioning additional hardware, sensors on the motor or axis itself. Sensorless monitoring modules eliminates this complexity by getting all necessary diagnostic data directly from the drive's electrical lines. Now we see a short video with a demonstration. Here we see a SafeOne sensorless module. All of our sensorless module variants will be installed in a similar way. So independently if it's a speed monitor or standstill monitor. The first that you need to do is to connect the 24-volt power supply and the safety input or output signals for start signals or acknowledge commands. To enable the monitoring, you must pick up the 3 signal phases, UV and W, or L1, L2, L3, that go from the frequency converter to the motor. You connect these phases in parallel directly to the inputs of the sensorless module. This simple method eliminates the need for any external encoder or sensors. As soon as the motor phases are connected, the module immediately begins its monitoring function. If we start the motor's movement via frequency converter or manually, the sensorless standstill monitor module instantly recognizes the motion by calculate or evaluate the voltage signal. Upon recognizing movement, it immediately opens the safety relay contacts, ensuring the machine remains in a safe state until standstill is achieved. This demonstrates the simplicity of installing and connecting the sensorless modules. We offer, next slide. We offer 3 different product variants for sensorless monitoring, each based on a specific signal evaluation method. We have speed monitor modules, still stand monitor, and rotational direction monitor module. The speed monitoring module measures the frequency output by the frequency inverter to the motor. It calculates the speed of the motor. Since the inverter's frequency is directly proportional to the motor's synchronous speed to device, the device can determine the current motor speed indirectly and without an external sensor. This module can be used for both 3-phase and 1-phase applications. The standstill monitoring module measures the electromagnetic force, EMF, the induced residual voltage. How it's working. As long as the motor is turning, a voltage is measured, regardless of where the motor has been switched off or is still running. This is because every asynchronous or synchronous motors act as a generator, producing a small voltage that our module can detect. The standstill monitor detects the safe stop when the measured voltage falls below a defined threshold, near 0 voltage. This is used for monitoring safe standstill. This module can also be used for both 3-phase and 1-phase motors. And the last product variants for motor monitoring or sensorless monitoring is the rotational direction monitoring module. It checks the phase sequence of the 1 to 3-phase motor lines. In 3-phase motors, the order in which the 3 phases UV and W, or L1, L2, L3 are connected determines the direction of rotation. The rotational direction monitor module analyzes the phase sequence of the supply current. This ensures that the motor only rotates in the intended or safe direction, which is a vital safety requirement to prevent risk. This is the technical explanation about our sensorless modules.
Thank you, Samuel. Let's see. Okay, let's hear from Steve. Steve, do you want to go over some benefits of sensorless drive monitoring?
Yeah, perfect. Thank you, David. Perfect. Okay, so both the DN3PD2 Safe Speed module and the DN3PS2 Standstill module boast flexible compatibility for different motor applications. They offer connectivity to three-phase and single-phase motors from 90-volt AC to 690-volt AC, including connection with VFDs, servo drives and motors, and star delta circuits for low and high-speed motor applications. David, it's not clicking. Perfect. Okay, so typical drive monitoring in the past has been done with encoders in the end of a motor shaft or proximity sensors, which watch a cam or gear to detect movement of a hazardous motion. When using a non-safe encoder, you should use two encoders on a single shaft, monitoring the hazardous motion for redundancy. Non-safe encoders is how speed monitoring was done originally due to the fact that safety-rated encoders were not available from many manufacturers until the last 10 years or so. Using redundant standard encoders requires having expensive devices out in the field to monitor a hazardous motion, as well as having expensive spare parts in stock, because if they're damaged, it usually leaves the machine in a stop status until it's fixed. As well, technology has changed throughout the years, and I've personally seen customers try to replace encoders without any luck, as the same model doesn't exist anymore, or they just plain old become hard to obtain. Many existing motor applications already have motors or encoders on them. So you ask, why could I not use this information from those encoders? Well, you can. The information that's already being used by these encoders can be shared via encoder splitter modules, but they're costly. They take up a large footprint inside a panel, and not to mention the fact that they're not safety rated either. So you'd still require, in most cases, a second encoder for a safety application. In saying this, safety rated encoders do exist now, and while they're expensive, they require less wiring than having two encoders hit in the field like non-safe encoders. The biggest issue, encoders do have a lifespan. Good quality ones generally have an expectancy of 20 years or 1 billion revolutions. However, working in the machine safety industry, I can tell you I've seen a lot of replacements already, and they haven't been out that long. They are an electromechanical device, and just like any electrical mechanical device, they'll wear out over time. In most cases, that 20 years or 1 billion revolutions can be, just as an example, if you were running 500 RPM, 24 hours per day, 365 days per year, that would actually only leave you with a life expectancy of about 4 years. That's just as an example. So this kind of thing should be calculated and considered so that you're making the right choice for this solution. Encoders can also be damaged quite easily in industrial environments. Things like moisture, cleaners, or even accidental damage from somebody working in the vicinity are things that we see as damage. Safety encoders still require being monitored by a safety PLC or a safety monitoring relay. The other variation of monitoring motion is to use two proximity switches to monitor a gear or a cog related to the hazardous motion. Proximity switches are not only not safe, but they're also devices which can be easily broken in the field by somebody simply working close by or environmental or cleaning. Many times proxy switches are replaced in these systems with alternative proxies as well, and which are not like, and that can give faults causing downtime. When using proximity switches to monitor motion, specific monitors are available to achieve the task, but they lack a lot of the programming abilities that are available today with sensorless technologies like DINA. Mechanical failures. One of the best things that I find with sensorless drive monitoring is the fact that there's no moving parts. Modules stay safe inside a cabinet and monitor the hazardous motion transparently. No mechanical parts in the field means less fault finding and more machinery uptime. Due to not requiring sensors or encoders, the only thing that needs to be installed is a few wires and the standstill or safe speed monitor in the panel. This is less intrusive on the machine, as well less likely to be manipulated or damaged in the field. Another great reason to use sensorless drive monitoring is the ease of installation. They're mounted typically inside the same panel where all the motor wiring already exists. So there's no reason to go out in the field and install sensors or encoders and run the wires back to those devices in the panel. So huge time savings. Here we see an example of a simple standstill wiring application. We have 24-volt DC for the control power of the standstill monitor. Then we take the single or three-phase information directly from the power wires that go to the motor that's creating the hazardous motion. And then we have an enabling path, which is typically used to unlock a door once the motion has come to a standstill or safe speed. For diagnostics, DINA offers two different methods to obtain quick information. Method one, the running status and the fault status are both displayed proudly on the front panel of the speed monitoring units for quick access. Method two, the use of the free proprietary software Go Beyond from DINA, which allows you to see not only real-time data, but real-time faults for diagnostics. This software is very intuitive for anyone who understands motor terminologies. Furthermore, if you require programming and installation, this can be done through our technical engineering services available from Schmersal. Or if it's just guidance that you're looking for, we have a systems and solutions team at Schmersal, as well. DINA can assist as well.
Okay, thank you, Steve. Let's go back to Daniel. Daniel, would you like to show off some of the DINA modules?
Of course. So thanks, Steve, for letting us know all the advantages and benefits of sensorless monitoring. And yeah, you already went quite deep into technical topics and the benefits, especially of our modules. I would like to now talk about more general features of the individual devices and show you also some application examples and use cases. And let's start with the speed monitor, the DN3PD2. We were talking about motor compatibility. So as Steve and Samuel mentioned, you can use it for 1- and 3-phase motors up to 690 volt AC. Also for motors in star delta circuit. And you can monitor safe minimum, maximum speed, or minimum or maximum speed. and also a speed range. The form factor it's a compact module, so with a very small form factor, with an overall width of only 22.5 millimeter. And of course, the unit has all relevant certifications: PLE, SIL3, SIL-CL3, and UL. And you also have LEDs, which show basically the operational readiness of the device and also the status of the output contacts. And you can see it here also on the front panel. There's a USB port, mini USB-A, which can be used to connect the PC. And on the PC, there needs to be the Go Beyond, which is, by the way, free. The Go Beyond software installed, and then you can use the Go Beyond software to parameterize the unit and to have some live real-time diagnostics. There are different device variants of the DN3PD2 speed monitor. The main differentiation criteria is whether the device has two signaling outputs, two non-safe signaling outputs additionally to the relay outputs, or two digital inputs, which can be used for operating mode switching or muting. By the way, the two outputs can be used to communicate, for example, with a non-safe PLC. Yeah. And then both of these variants are available for different voltage ranges. So we have the low voltage range from 90 volt to 690 volt AC. And oh no, this is the standard voltage range, sorry. And then we have the low voltage range from 24 volts to 124 volts AC. And on top of that, these two of these different variants are also usable for different frequency ranges. So we have the standard frequency range from 0.5 Hertz to 1200 Hertz, and the extended frequency range from 100 Hertz to 1650 Hertz. And yeah, all of this then together we come down to 6 device variants, taking into account all these different features. And on the next slide, I brought you a nice success story or application example we did with one customer related to high-speed turbine monitoring. What you see here is an environmentally friendly cooling device for industrial processes, and it contains turbines, and these turbines run at a high speed. The maximum speed is 88,500 RPM, and the requirement here was to monitor the speed of the 2 turbine drives without using complex sensor technology, because there was also space limitations, and additionally we had the PLE requirement. And yeah, the DN3PD2 sensorless speed monitor was the perfect fit in this case, and it meets all the requirements. And now the customer has a safe cooling device and is happy. Yeah. The next compact module out of our portfolio, which I would like to tell you more about, is the DN3PS2, the standstill monitor. It can be used for the same type of motors as the speed monitor. It has also the same form factor. It can be parameterized, but you don't need the software to do the parameterization. You can parameterize the switching thresholds between 50 to 500 millivolt and restart delays. And to do the parameterization, there's a set button you can see here on the front panel of the unit. And it of course has also all relevant certifications: PLE, SIL3, SIL-CL3, UL, and also it comes with LEDs, status LEDs, which also show here the operational readiness and status of the contact outputs. And yeah, parameterization can happen on the front panel by means of the Z button, as I already mentioned. The standstill monitor is mainly used for safe door access or to control protective doors or the protective cover releases. And here I brought an example related to mixing and granulation machines. So we had a customer. We have a customer who's producing spiral mixes. And as you can see here on the picture, there's a mixing tub, then the actual mixing hook, which is fixed to the mixing head. And the challenge is here, the problem or the task was here to control the lifting of this mixing head out of the mixing tub, so that it is only possible to lift the head out of the tub when the mixer or the mixing hook is at standstill. And in this case, the DN3PS2 fulfills all the requirements of this application. And yeah, also in this case, we made the customer happy. In general, it can be used not only related to mixers or granulation machines. You have similar, let me say, challenges when it comes to milling machines, saws, centrifuges, or cutters, and many more. So, for example, on the next slide here, I brought you an application example where we use both. We use the standstill monitor in combination with the speed monitor. And this application example comes from the wood processing industry, and especially it's related to an edge banding machine. And here we monitor with the DN3PS2 in one machine up to 7 cutters. And in parallel, we use the DN3PD2 to monitor the speed, the maximum speed of a press unit. Last but not least, the DN3PR2, our rotational direction monitor, which you can see here on that picture. Oh, this was too quick, sorry for that. Let me go back. Yeah, this is correct. Okay. This one can be used only for 3-phase motor. So you need all 3 phases due to the operational principle, because as Samuel explained already, we measure the frequency of the rotating field and then we evaluate basically the rotation or the rotational direction of the rotation based on the phase position of the individual voltages. Yeah. And this is why we need all 3 phases. And of course, this device also got all the relevant certifications, PLE, CL3, CL3, and UL. Has the same dimensions as the other devices, and it doesn't require any parameterization. So this is really plug and play. Okay, what is a typical application? Yeah, rotational direction you have when it comes to conveying and material handling. So, for example, in context of with a conveyor belt, to assure that it is running in the correct direction, the DN3PR1 can be used. Other applications would be industrial ventilation systems. So here you also need to assure that they move the air, for example, in the right direction. This is very important. Okay, so and finally, I have a comparison of the sensorless monitoring functions, which each device can do. So here in this overview, you see the speed monitor DN3PD2 can do safe speed range, safe limited speed, safe speed monitoring. The standstill monitor DN3PS2 can do safe torque off, and the rotational direction monitor DN3PR2, PR1, again, the same mistake, sorry for that, can do safe direction. That's it about the units.
You have a very good lineup of products there.
Thanks.
And earlier you also mentioned that you have software.
Exactly.
So let's see if we can do a quick demo of the Go Beyond software. So Samuel,
Yes.
you want to take that away?
Yeah, 1 second before start. The Go Beyond software has a user-friendly design and a logically structured interface. So let's start and see it together, how the software is looking and how easy it is to use it. So could you start? So, the first view is the Go Beyond software gives us the option to resume recently opened projects or to create a new one. To start a new project, we need first to select the correct module that we intend to install or that are installed. And you have on the right side an overview of the different function of every single module. In our case, we select as example the 34PD10, and we jump automatically or move to the configuration page where we can set the project data, for example, the name and author of the project, which is important for later documentation. And the tab parameterization, here we can set the main safety rules. This means setting the maximum and minimum frequency or speed limits. You also set delay times and how the module should be reset after stop. In the advanced settings tab, you can perform fine-tuning. You can adjust how often the modules measure the frequency signal in a cycle, or set another sensitivity. You can activate phase monitoring or modify the extended wire break detection. These settings ensure very accurate safety checks. The tab machine data offer other function or options to set. You can set the physical drive parameters like axis type, number of motor poles, and gear ratios. The software then automatically calculates the necessary conversion, turning the mechanical limits, the speed, into the corresponding electrical frequency thresholds. This simplifies configuration by eliminating the need for manual calculation before applying the safety limits in the parameterization tab. We also have the option to set a password for the module to protect it against undesired or accidental changes. And to transfer the project to the module, we navigate to the interface screen and select the appropriate COM port. Once the connection is successful, we can transfer the project. By clicking Write to Device, all configured parameters are transferred. The generated parameterization protocol provides a complete documented record of all settings. It will be done automatically. In the diagnostic area, we had the option to see a live monitoring of the actual speed signal and the status of the safety outputs. This is crucial for immediately verifying that the device is operating correctly under different speed conditions. The view of latch data and system data provide necessary diagnostics information. And the most important part or a key function is the validation option. This process verifies the correct function of the defined safety limits, and utilizing automatic validation, the software checks the integrity against a set of predefined validation levels. Upon successful completion, the software generates the required proof of functional safety and makes it available as a PDF document. This PDF serves as the official proof of commissioning, confirming that the system is ready and complies with all safety standards. As shown, Our Go Beyond software is designed to be very user-friendly and logically structured. We are confident that this ease of use guarantees that the product will be loved by its users.
Okay, thank you, Samuel. That software looks really easy to use. So at this time, we've got a couple more application examples to show you. And I think we're going to go to Daniel. I believe you have the first one.
Yes, exactly. I would like to tell you about another success story related to Standstill, our Standstill monitor, the DN3PS2. And this is very interesting. It's related to the safe access to centrifuges. For those who don't know what a centrifuge is actually doing, so it's a machine that is being used in, for example, chemical processing industry, food production, pharmaceuticals, or also in wastewater treatment. And it separates basically substances of different densities by spinning them at the high speed. And the challenge here is that the rundown time of a centrifuge, the rundown until the complete standstill, highly depends on its filling level and also on the mass distribution of the rotor. And for sure, you can, for example, use a fixed time relay with a fixed rundown time, for example, the maximum rundown time, to control the protective door or to unlock it safely. But let's say when the centrifuge is only partially filled, the rundown time is much shorter, and so the actual standstill occurs much earlier. And then you have waiting time, so the operator must wait for the maximum time, and that's a waste of time, and it lowers the productivity and reduces the machine availability. The standstill monitor, you can avoid this problem. You can not only make the centrifuge safe, but also can optimize the process. So the DN3PS2 standstill monitor can detect in real time whether there's an actual rotation of the centrifuge or not. And then when it is, or when the rotor really came to a stop at standstill, it immediately stops, or it immediately enables the door release. And so the customer basically has both an improved operational safety and also a more efficient process. So faster access to the centrifuge, higher productivity. So you have extended effective machine running time, shorter waiting times, and thus an improved process efficiency. And in the end, this also leads to a cost saving. So you have then a safe centrifuge and improved process. This is a nice example, I would say.
Yeah, thank you, Daniel. Steve, I believe you also have a success story from one of your Canadian customers.
Yes, thanks, David. Good story there, Daniel. This customer, they had 10 different pyramid rollers, which were high use, and they were deemed by our Ministry of Labor as requiring safeguarding. The reason was the workers had access to the pinch points, and they were unavoidable. And this was a result from the machine running too fast. The customer tried to address these safety upgrades internally. However, upon a follow-up inspection from the ministry, it was determined that the machines were still not safe to use and that the customer was actually negligent. The ministry locked out all 10 of their machines. They were all 10 of them were pyramid rollers like this. We brainstormed with one of our integrators. We discussed a few different ideas, finally settling with the operator being able to operate the machine in 2 different modes. Those 2 modes were either running full speed outside of a light curtain, or if they were interrupting the light curtain, they would run at a safe reduced speed. Now, to help better understand, these pyramid rollers, they make ductwork for commercial and industrial applications. They basically roll steel. The machines take a flat piece of metal and turn it into circles, essentially. The crushing point or draw-in from the rollers was the hazard. The reason you don't want the rollers to stop is because the pyramid roller, if you were to stop it midway, it can actually kink or bend the sheet metal. So it needs to keep moving in a smooth, consistent motion. What we did was we fenced in the pyramid roller, giving a normal function of the machine through the use of a double foot pedal for forward and reverse operations, and then a set of light curtains and a door to protect that area. The light curtains were not interrupted. We put the light curtain and the large interlock door into the application to give the worker access to the machine for parts removal and for machine adjustment. But the light curtain itself was not interrupted when the steel was moving through it. It would just be interrupted when the operator's hand or leg got in the way. It's not advancing, David. Sorry, it's not done, sorry. Go backwards again. If you broke the light curtain while the beam was, or if you broke the light curtain beam while it was in operation with more than just the sheet metal, like your hand or your leg, pyramid roller would reduce to a safe speed of less than 250 millimeters per second. The DINA DN3PD2 took care of this function by not putting the machine into an e-stop if the pyramid roller was running at the correct speed. If the curtain was unobstructed, the machine would run at a normal speed of 430 millimeters per second. The slowdown time between the 2 speeds was less than 1/10 of a second, which met the requirements of getting access to the hazard at a safe speed. This application of safe speed monitoring and other safety devices allowed the company to keep the existing machinery in play. The estimated replacement to the machinery, which already had similar functions for those 10 machines, was upwards of $500,000. Our application costs less than half of that for all 10 machines, and that's not just the standstill monitor or the safe speed monitor. It's also your fencing, your light curtains, your safety pedals, so on and so forth. Our application cost being at less than half of that for the 10 machines was a huge benefit, as the workers actually liked using the old machines. They were familiar with them. So the only thing that needed to take place now was training on how to use the machine with the new safety system. We worked heavily with the operators and the integrator just so that we could understand how they were using the machine and what needed to take place, and they were really satisfied with the outcome of these integrations.
Okay, thank you, Steve. We are just about done. We're going to do a little bit of a summary, and if you have any questions, now would be a good time to start putting them into the questions field. Here we go. So a couple of key takeaways from this session.
Okay, so cost savings. Not only do we not require expensive parts to monitor, we also don't need to drag wires back to the panel. There's also huge cost savings from the diagnostic standpoint, as there's no need to actually go into the field to see if the electromechanical devices require repair or replacement. For commissioning, it's really quick commissioning. There's really no requirement for fuses either. In fact, we don't put fuses in the installation. It's directly hooked up to the motor at all times. From a space savings It's a small 25.4 millimeter wide body, and that's the only thing that's actually required in the panel additionally. Retrofitting is very easy, as it's only a few wires to connect to the monitoring devices, and changing parameters is a breeze with either the touch button set up on the DN3PS2 or set up inside the Go Beyond software for the DN3PD2.
Okay, so now it's time for some questions and answers. We've got some guys from DINA, so you can hear answers directly from them. Let's see. First of all, is it possible to monitor safe limited speed and safe operational stop with one device?
Let me answer this question. In general, it depends on the application. So by definition, safe operating stop is really stand still. And this can be done with the standstill monitor. And SLS you can do with the speed monitor. However, we can, with the speed monitor, we can monitor frequency down to 0.5 Hertz. So for some applications, this is sufficient as is STO and or safe operating stop. Sorry, and yeah, but per definition, no. So you really need then two devices. Yeah.
Okay. Question from one of our audience members. Can the speed monitor detect an overhauling load, one that is spinning faster than it is commanded to, recommended to?
Can you repeat the question? What?
Can the speed monitor detect an overhauling load, one that is spinning faster than it's supposed to?
I didn't understood it acoustically. When it's spinning faster than it should do.
Yes.
So, I mean, detect maximum speed.
Yes.
The speed monitor, yes, it can. Yeah, this is one main function: detect maximum speed, minimum speed, or speed range. Yes.
Okay. Is there a cost for any of the software?
No, the software is free of charge. Just can be downloaded on our website.
Okay. You need to have one module per motor or drive.
Yes, exactly. Yeah. So you need one compact module per drive. Yeah. Yeah.
Okay. And what is the response time of the standstill monitor when the motor starts?
The
Response.
Oh, sorry. Okay, you can also answer this question. Yeah, please feel free. Yes.
Yes. The response time for a standstill monitor can be adjustable and set it from 0.5 to seconds to 40 seconds.
Okay. Well, I think that's all of the questions we have so far. So just to sum up, we do have a couple of white papers that are available in the handout section. This feature of safe speed monitoring and a paper called Sensorless Standstill Monitoring. And thank you to DINA for providing both of those. We also have a information sheet on some of the products that were presented today in our tech brief, DINA Safe Drive and Standstill Monitors. And if you don't get to download them from here, they are also available on our website, which is schmersalusa.com. You can find that in the products section. And then we have a special page in our additional products section for DINA controllers.
And David, I'm not sure if you mentioned it, but the handouts are available right inside the go-to webinar in the control panel under
Yep.
handouts.
So with that, I would like to thank everybody for attending, and special thanks to Steve Lang, Daniel Metz, and Samuel Iacierno. If any of you, and thank you everybody else for attending as well. If you need to contact any of us, our contact information is on the screen here now, including our systems and solutions team. And the session was recorded, so we will provide that to you either later today or tomorrow. And please have a safe day. And thank you for joining us today.
Thank you, everyone.
Thanks, David.
Thank you.